Welcome back, everyone. We are doing Know It Notes for 1-7, Simplifying Expressions. This lesson is actually one we'll probably take 2 days to do examples and activities for in class because it covers such important topics on combining like terms, the distributive property, and order of operations. We're going to start with some vocabulary. First one is terms. The terms of an expression are the parts to be added or subtracted. So down here we have 3 terms that are going to be combined: 4x, 3x, and 2. So this has 3 terms. Like terms have the same variables raised to the same powers, and they have to be exactly the same except for the number in front of them. Okay? So x and x squared, not like terms. Okay? X squared and 5x squared, those are like terms. So like terms have to be exactly the same. So we have 4x and 3x here on this page. Those are like terms. All the plain numbers, the constants, those are like terms also, but not 3x and 4x squared. Could not combine those. A coefficient, this is also on your vocabulary list. A coefficient is the number multiplied in front of a variable. Like terms have different coefficients usually, and anytime we see a variable without a coefficient, that means it has a hidden 1 in front. Okay. Since these terms x squared and 3x are not like terms, we couldn't actually combine them any further. We would just have to leave this as is. Most of the next few slides, you're not going to actually write anything down in your Know It notes. You're just going to be paying attention. If you see examples you'd like to add to your notes on the sides where there aren't other things, feel free. We combine like terms basically by using the distributive property. You might not think of it that way in your head, but that's really what you're doing. You're pulling out the parts that are pulling out the part that's the same, the variable, and adding or subtracting the coefficients that are in front. So you can see that if I had, for example, originally it was 7x minus 4x, that would be 3x. If it's squared, it would just be 3x squared. Okay. The variable stays the same. I like to think of it that it's like a little label, right? So I have A xylophones minus B xylophones, and when I'm done, I still have xylophones. So we're just going to try a couple here quickly together. Right? Like I said, you're going to add the coefficients together and keep the variables the same. So in this case, 16 plus 84 makes 100, right? 84 plus 10 would be 94. Another 6 makes 100. And the label or the variable is P. Don't forget to follow the rules of integer operations, so you can zap that if that helps you. So we're really adding negative 20 and negative 8.5, and we get negative 28.5, and they're all t's. Now on C, be careful because we've got some m squareds here at the front, and we've got some m squareds here at the end. And let's zap those. I can go back and zap these since I didn't do it before. But in the middle, we've got m cubes, and those can't be combined with the other m squareds. So I have 3m squared plus negative 1m squared. Probably should have put the 1 there. That would also be useful. Let's squeeze it in. Okay. Makes 2m squared. And then plus the m cubed. The order doesn't really make a big difference. Moving on to the distributive property, you should all remember this from last year. Ms. Walters swears that she and Mr. Olson and Ms. Covington all did tons of distributive property. So this is the rainbow property. Right? you're going to take that 4 and you're going to multiply it by everything on the inside. So we get 4 times m, you can just write those right next to each other, plus 4 times 2n. Well, 4 times 2 is 8. We just multiply those together and then keep the n on there. Right? On this next one, we've got kind of a two-step problem. So we take our 2 and multiply it by the 3x, and that gives us 6x's, plus 2 times y is 2y's, plus 5x. And now I can go ahead and combine my like terms. We always want to go as far as we can, but not too far. Right? And we get 11x's plus 2y's. We can't combine these because they're not like terms. So this is most definitely not 13xy. Okay, we just stop there once we have like, no more like terms. One more vocabulary, I think it was actually the first one on your list, but I chose to do it afterwards, and that is order of operations. So underneath there, you don't need a bunch of sentences. You can just write the PEMDAS, please excuse my dear Aunt Sally, and what each one stands for. So P stands for parentheses and other grouping symbols like brackets, which also tell you to multiply, and the division bar and absolute value bars. Those are all different grouping symbols that tell us that's what we have to do stuff inside those before we do anything else. Exponents, that's an easy one. M and D, I keep them together because they are not, one is not more important than the other. Multiply and divide in order from left to right. So we just start at the left and work our way across for all multiplication and division. And then, of course, A and S, add and subtract in order from left to right. Same thing. Addition is not more important than subtraction. Right? We do them all in order from left to right. And if you zip zap, frankly, you won't even really have any subtraction to worry about. Remember, if I've gone too fast, just pause it and then continue on when you're ready. I have a few examples here. A couple of them I already completed, and we'll do the last one all together. 3 squared minus 1 plus 2 cubed. We do our parentheses, but there aren't any, so we just move right on to our exponents. And so we have 3 squared is 9 minus 1. There's nothing I can do about that yet. And then 2 cubed is 8. And now we're going to add and subtract in order from left to right. So 9 minus 1 is 8, plus another 8 makes 16. Let's move to the one below it now. We've got some brackets and some parentheses. We're going to start with the innermost set of parentheses. So that's to do 8 minus 13. Zip zap it. And we get negative 5 from the inside. Notice I recopied the whole problem, everything else around it, not just doing little bits at a time. Now I'm going to multiply negative 2 times negative 5, and I get positive 10. And I rewrite it. You can use brackets or parentheses once you don't have both. When we have both, we alternate between them. And then 3 times 10 obviously is 30. For the last one, 14 minus 8 all over 2 plus 1 times 2. The division bar, we always do whatever's on top, we do whatever's on the bottom, and the last thing would be to do the division. So 14 minus 8 is 6. And then on the bottom, I have to remember to do multiplication before addition. So I have 2 plus 2. Don't be fooled there. It's not going to be 6 on the bottom. It's actually going to be 4. And 6 over 4, you can just reduce it and leave it as 3 halves. If you prefer to write 1 1/2, it's not wrong, but in algebra, it's always fine to leave things as improper fractions. On your notes, you do have to put at least one example from order of operations and combining like terms at the bottom in those boxes. So if you need to go back and fill those in, you can do that, or you can make up your own examples too, whichever you prefer. Thanks for listening. See you tomorrow.